The O2 sensor outputs a signal proportional to the oxygen content of the exhaust gases. The higher the oxygen level, the lower the output voltage. At full oxygen, it will output close to 0 volts, and at full rich, or excess fuel mixture, it will output close to 0.95 volts. In actuality, the O2 sensor should always be changing from 0.15 to 0.85 volts every second. This corresponds to a frequency of 1 Hz. A graphing meter, such as the ADP Scope 1, is preferable to view this signal directly. You may also use the graphing feature of the ADP Scan 1 Pro to view the O2 sensor waveform. Most OBD2 systems have a 4-wire O2 sensor. These wires are the 2 heater wires, the signal, and the signal ground. The 2 heater wires are ground and 12 volts, respectively. The signal wire tends to be the black wire, and the signal ground, the gray one. The ADP Scan 1 is sufficient to test the O2 sensor. But if the ECM reading is wrong, as in a faulty O2 ground, the reading will also be wrong. Beware, the O2 ground may be different than the general ECM ground. Goose the throttle to wide open a few times if the O2 sensor signal is swinging from 0.1 to 0.8 volts, then the O2 sensor is connected. Leave the engine to idle for 3 minutes, then goose the throttle again. If the O2 sensor changes from 0.1 to 0.8 volts, then do a frequency test. Raise RPM to 2500 and make sure that the O2 sensor changes at least once per second. If so, then the O2 sensor is fine. If the previous test passed but the O2 does not change at 2500 RPM, then you have a mixture problem. Do not replace the O2 sensor if it passes the swing test. If the O2 signal stays low, but changes when you goose the throttle, then you have a lean condition, such as a vacuum leak, loose vacuum hose, leaky brake booster, or other type of vacuum leak. If the O2 signal is always high but changes with the goose test, then you have a rich condition, such as a leaky injector, filled evap canister, or stuck open EGR valve. Fuel trims are also used to test the O2 sensor. This PID on the scanner works as follows. If it is above 10%, then your problem is a lean condition. If fuel trims are below -10%, then you have a rich condition. Use the O2 sensor signal graph and the short-term fuel trims while moving a propane tool through the intake gaskets and hoses. Take all precautions due to a fire hazard. As soon as the vacuum leak is reached, you'll see a rise in O2 sensor voltage and a shift in fuel trims. It is estimated that up to 60% of all O2 sensors are replaced unnecessarily. Finally, all O2 sensors have to operate at 600 degrees Fahrenheit. Make sure that the O2 sensor heater is working properly. Do a current reading. The heater should draw at least 1 amp of current when fully operational.